Feed rate and spindle speed explained for CNC woodworking. If you've ever worked with a CNC router, you probably know this feeling. You finish a cut, look at the material, and suddenly notice burned edges, rough surfaces, chipped plywood, vibration marks, or even a broken router bit. And honestly, this is one of the biggest frustrations in CNC woodworking. Because even with an expensive CNC machine and high-quality materials, poor settings can completely destroy the final result. But here's something extremely important. In CNC woodworking, the machine alone doesn't create perfect cuts. The real magic happens when feed rate, spindle speed, tooling, and material all work together correctly. So today, we're going to break down one of the most important concepts in CNC machining: feed rate and spindle speed. And by the end of this video, you'll understand why these settings have such a huge impact on cut quality, edge finish, tool life, and overall CNC performance. What is feed rate? Feed rate is the speed at which the CNC machine moves the router bit through the material. In simple words, it controls how fast the cut happens. Usually, feed rate is measured in millimeters per minute or meters per minute. This setting directly affects cutting quality, heat generation, vibration, and edge smoothness. A properly adjusted feed rate allows the router bit to remove material efficiently without overheating or damaging the wood. But when feed rate is incorrect, problems appear very quickly. What happens when feed rate is too slow? This is one of the most common beginner mistakes. Many people think slower cutting automatically means better precision. But in reality, when the machine moves too slowly, the router bit stays in contact with the wood for too long. That creates excessive heat. And heat creates burn marks, dark edges, smoke, and rapid tool wear. Dense hardwoods like oak, walnut, maple, and cherry are especially sensitive to burning. A slow feed rate can also dull the bit much faster because the tool is rubbing instead of cutting efficiently. What happens when feed rate is too fast? Now let's look at the opposite problem. If feed rate becomes too aggressive, the bit no longer cuts smoothly through the material. Instead, it starts forcing the fibers apart. This can create tear out, splintering, rough edges, vibration, and unstable cutting. In extreme situations, the router bit may even break. Plywood and veneered materials are especially vulnerable because the outer layers can chip very easily. This is why professional CNC operators carefully balance cutting speed and cutting quality. What is spindle speed? Spindle speed refers to how fast the CNC spindle rotates the router bit. This value is measured in RPM, rotations per minute. The spindle may spin at 12,000 RPM, 18,000 RPM, or even 24,000 RPM depending on the machine and application. And this speed dramatically affects surface finish, heat generation, chip evacuation, and cutting efficiency. Finding the correct spindle speed is essential for clean and stable cuts. Why feed rate and RPM must work together? This is where CNC machining becomes truly technical. Feed rate and spindle speed cannot be adjusted independently. They must work together in balance. For example, high RPM combined with slow feed rate creates heat and burning, while low RPM combined with aggressive feed rate creates vibration and tear out. Professional CNC operators constantly optimize these values depending on the material, the router bit, cutting depth, and machining strategy. And honestly, this balancing process is one of the biggest skills in CNC woodworking. Understanding chip load is one of the most important concepts in CNC machining. It represents the amount of material removed by each cutting edge during one spindle rotation. And this directly affects heat, tool life, cutting efficiency, and surface finish. A proper chip load helps remove wood chips efficiently and keeps the bit cooler. When chip load is too small, the bit rubs instead of cutting. When chip load is too large, the machine becomes unstable. Professional CNC machining is all about finding this perfect balance. Different materials require different settings. One of the biggest mistakes beginners make is using the same settings for every material. But different woods behave completely differently during CNC machining. MDF cuts relatively easily but creates enormous amounts of dust. Plywood requires careful tuning to avoid splintering. Hardwoods like oak and walnut generate more heat and require sharper tooling. Softwoods may compress or tear more easily. That's why experienced CNC operators always adapt their settings based on the material being machined. Sharp tools make a huge difference. Even perfect settings cannot compensate for a dull router bit. Sharp tools cut cleaner, generate less heat, reduce vibration, and improve edge quality dramatically. Meanwhile, dull bits create burning, rough finishes, unstable cutting, and excessive stress on the machine. Professional workshops constantly monitor tool wear because sharp tooling is essential for maintaining high production quality. Dust extraction and cooling matter. Too many people underestimate the importance of dust extraction. But trapped chips and dust increase heat extremely quickly. Good dust extraction improves cooling, visibility, cut quality, and tool life. This becomes especially important when machining MDF because MDF creates massive amounts of fine dust. Modern professional CNC shops invest heavily in strong vacuum and dust collection systems for this exact reason. Final thoughts: feed rate and spindle speed are two of the most important settings in CNC woodworking. And honestly, understanding these concepts is one of the biggest steps toward achieving professional CNC results. Because the difference between rough cuts and clean cuts, burned edges and smooth finishes, broken bits and efficient machining, often comes down to proper optimization. The right balance of speed, RPM, tooling, material, and cutting strategy can completely transform the quality of your CNC work. At the end of the day, CNC woodworking is not only about powerful machines. It's about precision, tuning, and understanding how every small adjustment affects the final result.